Hello students, welcome to our AriserTalent. I am your maths teacher Arpita Sharma. Students, we are discussing chapter probability, and in that chain or series or whatever you want to say, like in that thing we have covered probability, the basic definition, the mathematical definition, and then we've discovered about the coins, the cards and coin, card and the dice. Okay, so we have done some questions based on some of one or two on the cards and the another one on the coins. Okay, and I have given you this question, right, and I've told you that these two are somewhat similar that we have done previously in our first question of the previous lecture, and these two are the things we have to understand that time. I hope you have done that, but just as a recall, I'm gonna solve it with you, right students? So what this question is saying, look here, three unbiased coins. Unbiased coins, that means they are like there is not any tricks and tacts. That simply unbiased coins are being tossed. They are number 3 and they are tossed together. Find the probability of getting all tails, 2 head, maximum 1 tail and at least 2 heads. So event occurrence, total events that may occur. Okay, so probable events, that's what it is all about, probability, probable, or you can say total events that can be possible. Are I'll say that will be 3 coins tossed. So head, we have talked about that. They are total in number 8. Okay, so head, tail, then head, tail, head, then tail, head. Now we are going to have 2 tails, 1 heads. Okay, tail, head, then head, tail, then tail, head, tail, and then there's another one which is tail. That's so simple, isn't it? These are the possible outcome. Okay, these are the possible outcomes. Now the question is asking, first part, all tails. Event occurred for all tails. This is only one T. So this is equals to PA. Okay, or you may write that NA event A implies that NA is equals to 1, right? But NS is equals to what? 1, 2, 3, 4, 5, 6, 7, 8. Total 8. So PA equals to 1 by 8. And this is your what, student? This is your answer. Answer number 1, all tails. Now the second one, 2 heads. For 2 hats, you may see here 2 hats right there. 2 hats, or I can use this. 2 hats, 2 hats, 2 hats, and no 2 hat, no 2 hat, no 2 hat, no 2 hat. There are 3 hats. So 2 hat, 2 hat, 2 hat. 3 2 hats or 2, right, 2 hats. We have done this particular question. No. Okay, 2 hats. So there are 1, 2, 3. Right, so 3. 3 are the event occur for 2 hats. Event occurs for 2 hats. Which are the possible outcomes here? That is head tail, then head tail head, and then tail head. These are 3. That means if this is event B, okay, event B, that means implies that NB equals to 3. This implies that probability of happening that event B is equals to what? NB by NS, that is simply 3 out of 8 situations. So this will be your answer for the second one. Now this is for second one. Now what is the third one, student? Tell me. The third one is maximum one tail. Maximum one tail. Now student, listen carefully. Maximum one tail means what and what are included? One tail, either this or 0 tail. This is the meaning of maximum one tail. The one with no tail will also be included. Okay, so implies that which and which were that? One tail. In the first one there is HHH. This one. Then the second one HHT. Then the third one HTH. Then the fourth one THH. Now after that we are having 2T, 2T, 2T and 3T. So they are out of context of all this one. So there are, if this event is event C, we are assuming that to be event C. In that case, N C is equals to 1, 2, 3 and 4. 4 implies that what we are looking for? PC, and that will be equals to 4 by 8, that is equals to 1 by 2, and this is what, students? This is our answer. Okay, this is the third one. Now at least 2 had. Now first you will be noting this complete question, and then we will talk about the fourth point. So just note that complete portion, students. Noted? Noted? Okay. So I am just rubbing this first portion. So this fourth portion, at least 2 heads. At least what? 2 heads. Okay. If I am talking about at least 2 heads, that means 2 head is necessary, 3 head can be good. There is no problem having 3 head, but 2 heads are important. Now, finding that we are having 1 and 2 head. Okay, this one is good. 1 and 2 head. Okay, good. 1 and 2 head. Good. 1 and 2 head. Good. 1 head, 1 head, 1 head. Not acceptable, not acceptable, not acceptable, not acceptable. So, first, second, third and fourth is the thing. So, at least 2 heads that will have these 4 things. So, possible outcomes that is HHH, two heads, right? HHH, HHT, then HTH, and then THH. These are the 4 outcomes. That means this implies that, and now this event is happened to be D, event D, event D. So, and D will be equals to, students mentioned it here, 1, 2, 3, 4, 4, and NS is equals to 8. This implies that probability of happening the event D is equals to ND by NS. This is nothing but 4 by 8, which will give you 1 by 2, and this 1 by 2, students, what? Your answer. Note this. Then we'll move to the next question. Okay. Okay, students, now the next question is, okay, students, so our next question is, yes, this, a bag contains 5 red balls, 8 white balls, 4 green balls and 7 black balls. If one ball is drawn at random, find the probability that it is black, green, no, black, red and not green. So, this is the question that you have to understand first, that what is being asked, what is given to you. So, if I am talking about the given things, I am having what in the language? First, we have to understand this question. Okay, let's understand. It's having a bag and having some number of balls. Number of balls are 5, 8 and 4. So, total number of balls, and 7 also. 7 plus 5 plus 8 plus 3. These are the total number of balls in that particular bag. Right. Now, students, listen to me very carefully when I am talking about total outcome. So, that will be the summation of these. Now, the favorable outcome I am talking about. So, the favorable outcome will change according to the question. Okay, so first question there will be black only, in the second there will be red only, and in third there is no green. If there is no green, that means that can be red, that can be white and that can be black. Okay, so we will deal with the one by one. So given is what, students? Given are the numbers of the balls we are having. So we are having red. First, we are having red balls. Okay. Red balls, white, black, green. So, I am having red balls equals to 5 white ball equals to 8, green balls equals to 4, and 7 black balls, right? 7 black balls and green ball 4, 8 white balls and 5 red. Right. So total number of balls, total numbers of balls, I can just simply add that 8 and 7, that is 15, 15 plus 5 is 20, 20 plus 4 is 24. That will give me 24 students, right or wrong? Right. Now this is what is equals to total number of outcome or total number of outcome, possible outcome. Or may I denote it with this NS, right? NS will be the same in all. Now, first point I am asking for the black. Probability of getting that black ball is what? What I have asked, that probability of or we can say like favorable outcome. Favorable outcome of getting a black ball is equals to, we are having these 24 number of total balls and in that 24 ball, total number of black ball are 7. So, the favorable outcome are what? From 24 there is only 7 black ball. So, 7 are the favorable outcome, student. Okay, then is equals to 7 and I'll have that as an A, right? This black, let's suppose this as event A. So, what will I write now? Probability of getting black ball equals to PA and which is equals to N A upon NS. And that will be equals to what, students? 7 is NA and 24. This is what your answer. This is your answer number 1. Now student, this is about the black one. Now we'll talk about the blue. No, now we'll talk about the red. There is no blue ball. Red. We'll call it as event B. It gonna be the event B. Now similarly student, we know that NS will be the same, that will be 24. Now same, I can write that favorable outcome of getting a black ball is getting a red ball is equals to what? The favorable outcome of getting a red ball equals to, how many red balls we are having? See, 5, and that will be equals to NB. This implies that PB will be equals to NB upon NS, and that's simply what? That's equals to 5 by 24. And this 5 by 24 is, my dear student, your answer. Answer number 2. Right. Now, we are going to have that third one, which is not green. Not green. This is your what? This is your even C. Right? Even C. If you are not having green, then how, what you can have this black ones, these white ones, this red ones. So that will be the summation. The summation of these three will be 7 and 8. What? 15. 15 plus 5 is 20. Okay. So total 20. Here I'll write favorable outcome. If it's not green, that can be 5 red ball, 8 white ball or 7 black ball, and that will give you 20, and that will be equals to NC. This implies that PC is equals to NC upon NS, and that will give you what? 20. NS is 20. Right or wrong, student? Right? So 20 by 25. 25 or 24? 24 it is. 24. So 20, that will be 10, that will be 12, that will be 5, that will be 6. So students, this is 5 by 6, which is your answer. You got the first one, you got the second one, you got the third one. Now note it completely. Okay, so noted? Right. Okay, now our next question is this. Allot 20, a lot of 20 bulbs contain 4 defective ones. One bulb is drawn at random from the lot. What is the probability that this bulb is defective? Okay, we got 20 bulbs. So there's some, you may say a utensil or something, and in that we have put some bulbs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. Right. This is a lot of 20 bulbs, and we got our 4 bulbs as defective. Randoms are here. We know from this figure, but we don't know when we are picking any bulb here according to the question. So we are having a lot of 20 bulbs. One bulb is drawn at random from the lot. From this lot, I have drawn a bulb randomly. I don't know which one is defective, which one is not, but there are certainly 4 bulbs which are defective in this particular lot of 20 bulbs. So 4 defective, 20 total, that means 16 are okay. So now what is the probability? So in this we have 20 bulbs, and in this 20 bulbs 4 are defective and 16 are good. They are okay. So this is total of 20 bulbs, 4 are defective, that means 16 are good. Now, what is the probability that the bulb is defective? If I am randomly picking a bulb from that, I am having simply number of total outcome and favorable outcome. Let's suppose it's being event A. Now, total outcome is obviously 20 and a favorable outcome. It should be defective one. Defective one is, actually it's an unfavorable condition, but according to our question, favorable is when it's defective. So that will be 4, simply 4. Now you have to put in all the language stuff. I'm just solving this question for you. 1 by 5 should be the answer. Now the second question, my dear students. The second question is here. Suppose the bulb that you have to do in your homework. Suppose the bulb is drawn in 1. Now this has been drawn. You have drawn the bulb from this. Now it is not defective and is not replaced. I have picked one bulb from that bag. Now how many bulbs remained in that? That is 19. And saying that this bulb is not defective, what I have drawn. So basically the 19, in that 19 we are having 15 number of good bulbs and 4 number of defective, because what I have drawn is not a defective one. It's saying that. So now one bulb is drawn at random from the rest. What the probability what this bulb is not defective? Now you have to calculate your favorable outcomes and the total outcome. And if I am removing this first one, okay. So you have to get through this and you have to use your brains that what could be the answer, and we'll meet with the second part only. I have done with the first part, right? You have to put in your language, otherwise it's done. Now for the second part, you have to do some brain exercise and we'll meet in our next lecture and we'll talk about solving this question. Okay, so till then, have some Ariser sheets and do the practice and take care. Bye-bye.